Hey guys, so we're starting our new chapter today. We're going to do rational expressions and equations. So we're going to be simplifying, multiplying and dividing, adding and subtracting, and solving. One of the biggest things we need to remember is that the first step is going to check if we need a factor or not. So let's look at our first lesson here. So we're going to simplify rational functions, okay? So let's actually remember what we can do for simplifying, okay? So let's think back in grammar school when we used to simplify fractions, right? So I'm going to break this down a little bit. 20 is 4 times 5. And 12 is 4 times 3. Now, because of this multiplication here, 4 over 4 would be the value of 1, so we can cancel them out, leaving 5/3. So these are fractions of equal value. That's what we did in grammar school. We're going to continue doing that, but we're going to do it with actual functions. Now, one thing to remember is this, because we make this mistake a lot. When we have something like this, where we have 2 plus 3 in the numerator and 2 in the denominator, that does not equal 3. We cannot cross off 2 and 2. Think about this. This would be 2 plus 3 is 5 over 2, and that can't reduce. Okay, so we have this mistake that we make all the time. One of the things I want to show you on how not to make a mistake is when there's an addition sign right there, you cannot cross terms out between that addition sign. When it's multiplication, you can cross it out. So that's one thing to remember, and I'm going to try to point that out as we go along. Now, here are a couple of reminders for factoring, because like I said before, a lot of your first steps are going to be doing that factoring. So always take out the greatest common factor first. Here's the difference of squares if we recognize it, right? A squared minus b squared. And then what we get is a plus b times a minus b square root, right? Square root of a squared. And then we have our two trinomials in which we can do our box or grouping depending on what works for you, okay? Now, for you guys, what we're going to do is we're not really going to identify the domain restrictions as a vertical asymptote or a point of discontinuity. We're just going to point out domain restrictions right now, okay? Now, domain restrictions means that 0 cannot be in the denominator, okay? So what we're going to do is find the domain restrictions before we simplify, okay? Here is an example of how we're going to simplify, okay? So factor first, because that's how we can find our domain restrictions. So when you factor, whether you do box or grouping, on the numerator here, we get x plus 2 times x minus 4. On the denominator, we get x minus 4 times x plus 3. This is where I want you guys to do your domain restrictions, okay? So what makes anything 0 in the denominator? So in other words, we're asking ourselves, what makes x minus 4 equals 0? And what makes x plus 3 equals 0? So with those two, that means we have two domain restrictions. We have 4 and 3. And right now, and -3, sorry. And right now, like I said, we're not going to identify those as vertical asymptotes or point of discontinuity. I just want you guys to know there's a restriction. It can't happen, right? We cannot divide by 0. All right, so after you do your domain restriction, then we're going to see if there's anything in common that we can cross out. Now remember, it's got to be that multiplication. It can't be that adding and subtracting. That's why we can cross out the x minus 4, x minus 4. But we cannot cross the x's out because we have that addition there. Does that make sense? Think about that a little bit. You have to cross them out as a group because in between the groups is the multiplication. And then that would be our final answer with the domain restrictions. Okay, if you want to look, this is where your domain restrictions come out. So domain restrictions could be a vertical asymptote, which is right here. Vertical asymptotes means that the graph would never cross it. And the point of discontinuity is this hole. Again, we just want to know the domain restrictions right now, not what type it is. All right, so first thing we're going to do is we are going to identify the domain restrictions if there's no factoring involved, okay? Which technically there's no factoring involved right now, okay? So if you look, what makes 8x squared equals 0, right? So we're doing domain restrictions right now. So divide both sides by 8, we get x squared equals 0. Take the square root of both sides and we get x equals 0. So the domain restriction is 0. Now, if we simplify, let's take this in steps. 40 and 8, what goes into 40 and what goes into 8? Well, you can use your factors if you need to, but we can say 40 is 8 times 5. We have 4 x's because that's how we get x to the 4th. All over, well, since there's an 8 there, I'm going to keep 8 on top because I know I can cross this out. And then we have 2 x's on the bottom because that would be x squared. Now we're going to cross out the common. So we can cross out the 8's and we can cross out the x's, 2 of them. What does that leave us with? That leaves us with 5, and x times x is x squared. So this is our simplified function, and this is our domain restriction. This is one type of question you might see during your practice work. Let's go over to some other ones. Example 1 here, as you can see, is already factored for us. Sometimes we'll run into that if we're lucky, right? So let's talk about the domain restrictions first. Remember, it's whatever is in our denominator, and we're going to set that equal to 0. So x plus 2 equals 0 and x plus 4 equals 0. So when we solve this, we get x equals -2 and x equals -4. Those are our domain restrictions. Now let's look at our simplified. Remember, we're going to cross out groups. So what group do you see? I see an x plus 2 and an x plus 2. Remember, we cannot cross out those x's. So we're left with x minus 5 all over x plus 4. And that is our simplified function. Okay, you know we're going to have to practice that factoring, right? And so first of all, let's factor and then do domain restrictions. We kind of want to get in that habit. So with factoring, what's the first thing we always look for? Greatest common factor. So if you look at the numerator, what's common here? Just don't look at the numbers, look at the variables too. So what do they have in common? They have an x, leaving us -5x squared plus 4x plus 6. Now I will tell you that we cannot factor this trinomial, so you can stop there. Okay, now we're going to do our domain restrictions. Remember, set that denominator, which is just in this case, just x equals 0. So that's done. So our domain restriction 0. Now let's look back at our factor form and say, what can we cross out? Remember, we can only cross out things that's multiplied. As you can see here, this is a full group. That's why I like parentheses, right? It talks about groups there. So if you see, you can cross out these x's. Don't forget to write your simplified function. So our simplified function is -5x squared plus 4x plus 6. Okay, let's try another one. Again, looking at factoring first. In that numerator, what's so special about this? It's the difference of squares. And if you forget that, remember it's on your first page here, the difference of squares, right? So I know it's a difference of squares, one, because I see two terms. I see the subtraction, and I see that I can take the square root here and square root here. So knowing that this is the difference of squares, this is x plus 2 times x minus 2. Don't forget to square root those. All over x plus 2. I'm going to put parentheses around there so I can think of it as a group, as I've been saying during this lesson. Let's look at domain restrictions. The denominator, set it equal to 0. So that means x equals -2. And by the way, I keep saying equals this and equals that for domain restriction, but really what we need to say is it can't equal. Okay, but I figured for the domain restriction, that's telling you that's what it can't equal. So we'll just keep it as that right now. All right, so now let's look at our simplified. So what grouping, right? What grouping can we cross out? X plus 2. Now, will there always be something to cross out? No, sometimes we get things that are already simplified. So there is our simplified function. All right, one more, and then you guys get to try this on your own, okay? Now, this looks a little bit more complicated, so we need to look at that factoring. What do we always do first with factoring? Greatest common factor. So let's look at the numerator here. Let's look at the numbers first. What's common between 2, 10, and 8? Hopefully you said 2. Now, don't forget that variable though. X cubed, x squared, and x. They all have an x. Okay, so if you have to write on another sheet of paper or on the side how you're going to take that greatest common factor out, remember we divided each term by this. Do so. Use that space if you need to. So 2x cubed divided by 2x is x squared. Negative 10x squared divided by 2x is negative 5x. And 8x divided by 2x is a positive 4. And again, I can double check my work because if I distributed that back in, I would get my 2x cubed minus 10x squared plus 8x. Okay, this time I also have to look at the denominator because these two examples we didn't have to factor the denominator, but in this case we do. Again, look at that greatest common factor first. Okay, so x cubed plus 2x squared minus 3x. Well, they all have an x in common, leaving us x squared plus 2x minus 3. Now we did the greatest common factor for numerator and denominator, but we also have to do our box or our grouping. So you keep the greatest common factor up front. Now, guys, I'm not going to show you how to factor right now. I'm just going to give you the answers for factoring. So if you wanted to practice your factoring right now, pause the video and try to do that factoring and see if you get the right answer, or call me over and we'll go through box or grouping if you need to. This comes out to x minus 4 times x minus 1. And this comes out to x minus 1 and x plus 3. All right, let's talk about domain restrictions, right? That's our next one. Now, one of the things that everybody forgets is I see that there are 3 x's. So there must be 3, at least, not at least, at most 3 domain restrictions. So I have to look at each of the multiplying, right? So here I have x equals 0. I have x minus 1 equals 0. And I have x plus 3 equals 0. This one's already solved, right? X equals 0, can't do anything with that. But this one, x equals 1, so there's a domain restriction at 1, and there's a domain restriction at -3. So in this case, there were 3 of them. Now let's look back at our factor form. What is it that we can cross out? Look at the grouping. Okay, so hopefully most of you have said x minus 1 first. Okay, that's kind of obvious right there. But there's one more thing. See these x's up front? This is all multiplication. So I can cross out this x and this x. Tricky. So what does that leave us with? Well, in the numerator, it leaves us with 2 parentheses x minus 4 over x plus 3. And again, I cannot cross those x's out because they are grouped together. All right, let's see how you're going to do with that practice. Call me over if you need to. All right,